All right. Thanks for everyone for joining us today for our Geotechnical Mine Closure Considerations webinar. Before we begin, just a couple of house rules. The session will last for 1 hour. We are recording today's webinar and a link will be sent through to all of you. If you have any questions during the session, please post it in the Q&A section within Zoom and we'll get to those during the question time. Let's kick off. For those who haven't heard of MEC, MEC is a global mining consultancy specializing in mine planning, on-site management, and technical services solutions for the international mining industry. Since 2005, MEC has grown into one of the leading consultancy firms with an experienced team of consultants specializing in both the open cut and underground mining for the coal and mineral sectors. Today's presenter is our very own MEC Mining's WA Manager and Technical Services Manager, Erin Sweeney. Erin is an experienced mining professional who has worked across a broad range of commodities, including gold, base metals, iron ore, and coal operations. Her background lies in geotechnical engineering, designing, modeling, and implementing cost-effective, innovative mine solutions in both site-based and in consultative roles. Over to you, Erin.
Thanks, Amelia. Thank you, everyone, for joining us today. The number of participants that we got is quite an indicator of just, I guess, how much people are really looking for a bit of guidance in this space. So hopefully today, as I move through a case study and some of the issues that we've encountered as we've tackled these kinds of problems, we can provide a little bit of insight into how they may be tackled. There are obviously many ways to skin a cat, and the case study that we're going to look at for a large open pit metals mine is probably more of a guidance. I'd love to be a bit more specific, but unfortunately that's not possible. So we'll just go through the problems, I guess, as generic understanding, and to give some guidance on how to tackle some of these problems, because they can be quite common across multiple different sites. Okay. So I'll run through this sort of rough agenda here. So we're going to have a quick look at some of the historical approaches to mining, just a brief sort of scene set, run through some of the relevant legislation guidelines, some best practice that's out there, and objectives for outcomes. So that's really, about finding what works best for all the stakeholders for the closure outcomes. So that might be, the local community, the government, and the legislative requirements, and the business as well. Juggling these things can be quite complex, and there's a lot of agreements that need to be made as you're sort of traveling through this process. We'll have a look at some of the assessments that have been undertaken that are appropriate to the complexity of the problem. And the case study is going to specifically focus around some of the in-pit waste dumps, some large-scale failures, and sites where you may have historical or culturally significant sites adjacent. So there's around 50,000 abandoned mines and minerals processing facilities across Australia presently. These have been around for a century, some of them, and some of them are probably more in the last century more so. Typically the approach was just to throw up maybe a fence, and there were some warning signs. Even if we go back even further in time, there probably wasn't even that in place. So the photos that we're looking at here are some from abandoned sites around WA. There's not really a lot stopping you from accessing these areas, so they're a great concern to the local community. These are underground mines, quite shallow, but there's some obvious consequences here for the local community if somebody wanders in and they didn't have the lay of the land. Over to the right there, you can see a bit of a backlash from the community about these mines. So the community is generally very antagonistic over this kind of issue, and they want to see mining companies step up and take more responsibility. And so the government follows suit. Usually the community leads and the government follows with legislation. And so what we're seeing now is this evolving process of more and more legislation that sits in around abandoned mines and mine closure. And particularly we're starting to see more and more interest in how we manage the community expectations, particularly with historical sites as well. So some of the guidelines and expectations will change over time. So we see them becoming increasingly more community focused and long-term focused as well. There's not really a federal guidance around this. So each state will have its own set of guidelines. And it's really up to you to understand what is applicable and what is best practice for that state. You may be working for a company where the expectations go well and truly above and beyond what the legislation looks like in order to meet community expectations. And certainly we're seeing a significant increase in that. The ESG space is blowing up right now, and closure plays a massive role in that. And we're seeing, shareholders become more and more vocal about these kinds of issues and where they're going to put their money. So it's pretty much your responsibility to stay on top of all these expectations, and there's a closure team that you would have to work with who would have a very solid understanding of that. But how you apply these strategies it's really important to understand how these issues interact with the strategies that you're going to apply. And we have certainly seen the result of where community issues or environmental issues that sort of overlap with those geotechnical issues can have devastating consequences on both the reputation of the company, the impact on the community, and the impact of, I guess, the mining reputation as a whole. And I guess one of the final points that I want to make here is, as you're sort of moving into this space, know what your area of expertise is. So if you don't have qualifications in tailing stems, exclude it from your scope and bring in somebody who does. They're very unique area and they require specific qualifications. So don't be giving advice on areas where you don't have the ticket to practice. So I'm coming to you from WA today, and I know many of the people who are watching us are from a lot of other states, and we're probably going to cover off some of those states' legislation as well. Throughout my career, I've sort of dealt with a few different states and the legislations that sit in around those. I've found that the WA documentation is potentially probably the closest to best practice that there is, and there's probably a lot more that you can do on top of that. But it is very good at guiding a thought process for you to actually, and providing almost a shopping list of tasks that you should tackle. So what we're looking here on the screen is the mine closure guidance plan. And this is very much an environmentally focused document, but it is about closure in general in WA. It is environmentally focused, as I said, but we've also just covered off that the overlap between geotech and environmental, they're very close, and the two issues can be quite interactive. So it's really important that you get across what they're asking for in this space. And in section 10 here, what we're drawing our attention to is this need for a monitoring framework. So closure doesn't just happen, you pick up the last bucket of ore and close the gate. Even if you've done a lovely closure plan and you've got everything sorted, you need to actually prove that what you're proposing will work and what you're putting in place actually will work. And the expectation is around that 10-year mark. I have seen proposed legislation suggest that could go up as far as 25 years, but presently my understanding is that it's around that 10-year mark. So what are you actually going to be doing and putting in place to prove that your plan is working over that 10-year period? And the other thing I think that's really important to pay close attention to here is that closure is it's a risk-based process. So you really have to understand your materials characterization, the local environment and climatic conditions, because these are going to have significant impacts. As we geotechs know, water is probably the #1 enemy of stability. And so understanding the variability in the climate that you have and how that's going to change over time. So we're not looking at a snapshot in time or a very short period of time as we are when we're mining. We're looking at something that's actually going to be extending for a much longer period of time and community expectations. So this is, I guess, the nuts and bolts of the legislation. This is a bit where if you're not doing these sorts of things, then this is where the fines start to come in. And the geotechnical considerations that sort of fall under this legislation require us to have a very good understanding of our sites. And there'll be a lot of discussion that sits in and around this abandonment bund that's a requirement in pretty much almost every state. And what we're actually doing to help our understanding of where that should go. So a geotechnical engineer should have adequate consideration of local geological structures and their influence on wall stability, the rock mass shear strength and the geological structures, particularly around water inflow. So we're looking at things like erosion, surface drainage patterns, groundwater fluctuations, seasonal changes, and the instability factors that sit in around this on our pit walls. Any reinforcements that have been applied and their potential to stay in place over long periods of time. So, you know, if you're looking at, say, buttressing or rock bolts, you know, how long are these things going to last? You know, what's their appropriateness for a closure situation? Obviously, the projected geometry, we all know that it's something that's not confined, is going to be a far more risk, particularly in a closure situation. The drilling and blasting procedures that have been applied throughout the life of mine and whether or not that's degraded the wall strength itself. And any monitoring that we're going to be putting in place or recommending for really long periods of time. So just narrowing in on this idea of the abandonment bund. And once again, we're looking at some WA documentation here from the MOSHAB guidelines. So this requirement for the abandonment bund. And there's some very interesting language in here that actually requires you to have a really good, long, hard think about it, even though they've got some guidance here on where this bund should go. This idea of potentially unstable pit edge zone is actually quite critical. So the recommendations that they're applying have been based on, you know, slope failures and tension crack measurements around Western Australia, and they've identified that this will typically result for weathered rock based on Australian standards definitions, that this would be a 25-degree mark or a projection line from the toe of where that starts, and for 45 degrees from unweathered rock. And there's a little diagram that they provide to help you understand that. And there's a few different scenarios if you read through the document that I've highlighted the link there below. And then you need to add another 10 meters on top of that. So the words here that are really important are potentially unstable. And this suggests that this is the area. So basically the onus is on you to consider whether or not this is actually appropriate or not. And hopefully if you've been working with your site for a long period of time, you'll have a good understanding of whether or not that's true. We want to have a look in Queensland, and this is just a snapshot of a piece. There's a lot more to this than this, but this is sort of some very relevant pieces of information. So whether or not, I guess at the closure point, the government is looking for a site that's rehabbed so that it's safe for humans and wildlife. It's not polluting, stable, and they're calling it an enclosure bund. And is able to sustain an agreed post-mining land use. And there's a few further goals that sit in there around preservation of specific European and Indigenous heritage sites that are registered. If we have a look at the Northern Territory, we can see there's a bit more of a focus on how the land's going to be used afterwards. And so we're looking at the socio-economic benefits that need to be maximised where possible. So we're looking at increased human interaction around the sites. So, you know, this idea of long-term use and, you know, opening up to the public becomes very important in, you know, how we define potentially unstable and for long periods of time, and how we're going to apply that. And then if we're having a look at Victoria, they're looking at a geotechnical risk zone, a GRZ. And once again, there's a big onus on understanding the impacts of this about adjacent infrastructure, land property, different environments, and how we're going to measure that. It tended to be less or shallower pits in Victoria. So we're seeing sort of the application of this 3 times the height of the batter plus the 20 meters offset. But once again, it's up to you to prove that this is appropriate. So I guess if we move into this idea of tackling this potentially unstable language, there's a little bit more guidance that's been provided, and in the picture on the left, what you can see is if you'd potentially applied those guidelines, you would have been in quite a bit of trouble because this failure is obviously quite significant and extending past what those guidelines would have expected. So you have MUSHAB guidelines suggesting that, and I think we're pretty much all using these sorts of guidelines. Factor of safety of 1.2, where no infrastructure is at risk, and 1.5, where infrastructure may be at risk. So one of the things to think about here is your abandonment bund or enclosement bund considered infrastructure in the context of closure? The case study that we looked at, we certainly considered that to be the case. So we were looking for a factor of safety of 1.5. Something else to think about is, factor of safety is just a number, and hopefully over the course of your operation, you've been doing mapping and modelling and back analyses and collecting rockfall data. You've got a database of failures and run out analyses. So hopefully you're getting closer to something that's going to give you a lot more certainty around that. So you're looking at something that's more probability of failure. Where you have complex problems, from rock mechanics type problems, particularly around structure, you're looking at a shear strength reduction factor. So these are probably more important things to consider and that provide greater certainty. And hopefully you've also got quite a bit of data around what your site has key sensitivities to as well, and how you're going to factor those into this sort of analysis. So the photo here was probably quite famous one, and so we've got the impact of some of this infrastructure that sits in behind the pit wall. So here we're drawing attention to this idea of the influence of groundwater pressures, of overtopping of creeks and riverbanks, and their impact on pit walls as well. So a bit more of a shopping list here from the MOSHAP guidelines. So we're having a look at making sure that we understand all these parameters, because once again, this probably would have occurred outside that 2545 geometry. So making sure that we actually understand the influence of these types of parameters and factors on the stability of our pit wall. Something else to have a think about is if your site is in a seismically active area, so where you have a lot of earthquakes, maybe you might have a tsunami that gets triggered. So how are you going to factor that into your stability assessments as well? So obviously we've sort of covered off a bit of the government legislative guidelines, and once again, it's up to you to sort of get in and get across those and understand what they mean and read those in full. This was not meant to be a sort of a briefing on what they are, just sort of draw attention to the idea that some of the language in them requires you to think a little bit more rather than just take it as very prescriptive. But you're also going to have client expectations, and they'll sit around, trying to get this signed off and across the line. Once again, you'll have certain companies that will have expectations that go above and beyond what the legislation looks like. So the case study that we're looking at, we're looking to provide guidance on the location of the abandonment bunds. So this was sort of a combination between your factor of safety of 1.5 and your projected line. So not just picking one or the other, but having a look at the two of those and seeing where would be a suitable place for the abandonment bund, and that would be acceptable to the local government body. And provide guidance on remediation, management, monitoring of the site. So we're looking at that closure period. So how do we prove that what we think is, we've done all our analysis, and then we need to prove that these things are actually going to be stable and that they meet the recommendations. And for anything that isn't stable, what do we actually need to do about that? How can we get it to a state of stability, or what do we have to actually be monitoring longer term to understand that, okay, it's not stable, but how do we manage this thing from not getting out of control in the future so we can limit the footprint of the site itself? And then some guidance around any of those remediation methods that might be required to open up historically or culturally significant sites that are going to be important for the local community to continue to access. So some of the factors that we were considering, and so the picture in this photo is of a coal site, and it's I think sort of a sandstone, and you can see the impact of erosion over time. It didn't take, we're not looking at, it's probably around the 10 to 20 year mark, and this is a significant amount of erosion. So how are you going to factor that into your analysis? There's a lot of papers out there sort of suggesting disturbance factors, which I would also agree with, but having a really clear understanding of how you're going to tackle the degradation of your rock mass is going to be really important. So once again, this definition of what is long-term. So you see a lot of the legislation sort of refer to this long-term stability. There's no numbers that have been put on that. So, as engineers, we like to be very specific and articulate, what's the number. So in this case, there's a lot of discussion with the mining company around how we're going to define what long-term is. And we had a look at 100 years as being our definition of long-term. That may or may not be appropriate for different cases. That was the one that we came up with because we had data on the local climate and climatic changes for 1 in 100-year events. So it was something we could reliably model to. And then definition of what is potentially unstable, as I said, factor of safety of 1.5 because of the Enclosement Bund, but that's something that you're going to have to rationalise. With sites, you may want something that's a little bit higher than that. For civil aspects, particularly if you've got a lot of access coming into the site, it's something you're going to have to grapple with. So there's some suggested guidance there, but it's really between you and the consultative process between the closure team and the government and communities and the like, to understand how you're going to define what this potentially unstable is and how you can do it in quantitative terms so that you've got something you can measure against. And then you've got the impacts of your long-term water pressures. So probably the vast majority of sites that I have worked at will have creek and river systems that operate in and around that are going to have different responses. They'll have seasonal responses to rainfall. So how does this change over time? You may want to bring in some climate change data and have a look at the impacts of that over time. We've covered off the degradation of rock mass and structures, particularly where you have tension cracks on the surface, so how you're going to sort those out so they won't erode away. And any management or remediation of areas that have become unstable. And once again, just highlighting that the complexity of modelling is appropriate, it needs to be appropriate for the complexity of the problem. So it's not appropriate to just use empirical, where you have very complex problems or limit equilibrium. You might need to start upping up, into those more and more complex numerical modelling programs to get the right answer, or to get greater insights into how this problem is evolving. So this is a very broad overview of the scope of work that we looked at. This was probably a couple of pages longer than this, but sort of can be summarised into how we tackle this problem. So we're going to provide advice on this long-term stability. So this 100-year period, looking at this 1 in 100-year event data. And determine any areas that may expand beyond the current boundaries. So anything that was going to make that footprint grow over that period of time. So obviously we want to put abandonment bund in there. We don't want that abandonment bund to become problematic in the future. We want to provide recommendations for how areas could be remediated to make sure it met the regulatory guidelines, so where it wasn't compliant, if that was possible, and identify local erosion points within the pit boundary, so understanding how we're going to redirect and manage water erosion around the site, particularly for very large type of events that have strong scouring impact. And advice on how to monitor this pre-closure state to confirm assumptions. So what are we going to use to monitor the pit state? So if we have a look at the in-pit waste dumps, so these were actually already in place, so it was fantastic, already buttressing the pit wall, so significant dump, nothing else needs to be done there. So looking through the risk assessment that we did for this and potential issues that could crop up over that period of time, some of the things we thought about and had to model was this progressively increasing water, so water running into the pit, and then fluctuations of that associated with seasonal fluctuations and the like. If we were to get slumping over a period of time, would that generate mini tsunamis, and how would that impact in the pit, and any monitoring instrumentation that we had? around there. The heavy surface erosion, so waste dumps are obviously going to be quite prone to heavier erosion and scouring. So how are you going to manage that process? Where they were on sort of more dipping foundations, just making sure that we had a good understanding of the stability there and making sure that any failures weren't going to creep back past the pit boundary and result in a unbuttressed situation. And then the compaction of the waste dump over time and how that was going to change with time. And so you're sort of just trying to validate some of these longer term assumptions. Bit of SponCom as well, so some of the capping that's sort of sitting around that to help manage some of the settlement that would occur, as you see quite common in coal mines as well. And basically we didn't really flag too many external concerns. It was just probably a bit of remediation and water management that was required for these sorts of sites, and so making sure that they were set up for long-term and really large scale sort of rainfall events. So the Abandonment Bund here could be quite safely put in place fairly close to the pit edge, and we use those MOSHAB guidelines and the 1.5 factor of safety line to provide some guidance there. The next site that we were concerned with was a pit with a large structure, and there's a historical site adjacent, so something that we want to reopen up to a community. So basically what we had to look at here was whether or not this fault structure was able to meet this longer term stability. In this case, there were some questions that sat in and around that, so we had to look at how we're going to remediate that. We also wanted to have a look at the significant amount of water. So as you can imagine, any tension cracking that you're getting near surface needs to be sorted out so you don't get erosion through and around them. The rock mass itself has anisotropic properties, so making sure that our modelling and the data that we had for that was adequate, and we're getting back analysis, increased data from all coordinating our databases for our rock mass strengths and the like, and our defect strengths. And then doing some SSR, so 2D numerical modelling, and then we also at one point had some 3D FLAC modelling for this area as well. So very briefly, so basically you can sort of see the impact here. So you've got certain structural component playing in, sort of indicating that one area here was not going to be stable for, potentially for that long period of time. But once again, you buttress that and you can get that number back up. So it's just a matter of making sure that we understood how much of that we need to do and verifying that process with modelling. And then we were very easily able to provide that 1.5 line with a great deal of confidence, and then put some monitoring in place to manage that over a longer period of time. So we're also looking at managing the water ingress, so making sure that we've got those the water management bunding in place, and where appropriate, some geofab can be used to redirect water and to manage erosion for longer periods of time. So you can get creative with this, and there's a lot of experts out there to help you with that. So for an area of a wall that has already failed, what you want to do is understand, is there anything you can actually do about that to limit the footprint, so to remediate it so that it doesn't continue to fail? If not, what do you actually have to do near the surface to manage it? So you can see something like, and this is not the site, this is just a photo from another site that had a failure. How would you manage erosion in this kind of environment? So how do you make this so that you're minimizing the footprint of this to continue to creep back over such long periods of time? So these are the kinds of issues that we're tackling. We look briefly at some backfill options. There are going to be a lot of sites where that's not possible due to the sheer volume of material that would be required. So if you've got a very deep mine, that's probably not going to be a viable option for you. So sort of managing this at the surface and trying to use this natural angle of repose to your advantage. So the civil response here was quite important. So once again, like most mine sites, there's a creek nearby, so making sure that we're covering this 1 in 100 year rainfall event so that the creek doesn't overtop and run in and generate a lot of problems. So making sure that we're reinforcing this area and so that it was compliant for this size of event, and that the creek was in the right location for that, so that the impact between any further eroding or degradation of this area was going to be well and truly away from natural infrastructure as well. And then making sure that we've got in place this will probably have a lot more monitoring around it. The risk is significantly higher. So doing that risk assessment to really understand, what are the likely longer term problems here. So BWPs, prisms, satellite monitoring, inclinometers, all very appropriate for this sort of area. And also having a look at, what kind of frequency should somebody be looking at this data? You as a geotech are probably not going to be around all the time to do a daily inspection like we do when we're, live operations. So how are we going to manage this over a long period of time with some remote type of operations or some sort of caretaker view as well? So I guess that sort of runs through a brief understanding of some of the problems that we've tackled. Obviously, there's a lot more than this that sit out there. This is very specific to, I guess, sort of those, metal style of mines, but there's certainly nothing stopping you from applying some of these strategies to other styles of mines, such as coal strip mining and the like. You probably want to modify some of those approaches a little bit more so they're appropriate for the site. But some of the recommendations for geotechs that I would put out there quite strongly, make sure that you assess and understand the current state of stability, understand how the environmental factors are going to change over time and what impact they're likely to have on stability. And if we're getting increasing data and information about climate change, so you need to come to some sort of agreement about whether or not that's going to be a component that you're going to throw into your analysis as well. You're going to want some government and company agreements about, what period of responsibility are we looking at here? So, as geos and geotechs, we probably have a really good understanding of, this never-ending periods of time and erosion and the like. So is it 500 years? Is it 5,000 years? Is it 100 years? Long term means a lot of things to a lot of people. So working out what's reasonable to the stakeholders as well is going to be a really important part of this. Making sure that you understand what potentially unstable means to your stakeholders as well, and you've all got a really good understanding of what that is and how you're going to tackle that. So getting agreement as you're going through this process on how you're tackling potentially unstable. Making sure that you're applying some strategies for buttressing and remediating, and that you're verifying these through modelling. And if you're using other tools, bolting and the like, how are they going to hold up over longer periods of time? What data have you got to help you understand these longer term implications for these kinds of controls? Putting in place this 10-year plus monitoring plan, you might have a problem that maybe it extends past that 10-year plan. Maybe the legislation is going to change and you might need something a little bit longer as you're sort of midway through this 10-year plan. So just trying to understand some of the limitations that are going to sit in around that when you're providing these recommendations. We were recommending regular inspections by a caretaker type and sort of aligning this with a TARP. So there's an escalation process. So you may not necessarily have an expert looking at this with great frequency, but maybe there's some sort of photo gathering, some very prescriptive guidelines around TARP monitoring, and there's an escalation process that's been identified so things don't get out of control and you suddenly have a runaway event. And potentially throwing in things like biannual inspections or data reviews by geotechnical engineers. Once again, this is going to be up to the site and the company themselves to understand what's going to be appropriate. So there's certainly not a recommendation that would just be it. You've got to actually have a think about it. Ensure that you fully understand the regulatory environment at the time of the assessment. So where you are, which state you're in, is going to be really important to understanding, what's the benchmark that you're working to. How is that changing over time? What are the community expectations around the local area that you're looking at as well? And how is that going to, how are they going to use the land after this site is done with it, so that you can actually apply the right level of risk assessment process to this as well. And only assess those for which you're qualified. I cannot stress this enough. We're starting to see increased interest in tailings dams, and people should not be tackling those problems unless they're qualified for them. And there's very specific qualifications. It'd be fantastic for you to go out and get them. I think that would be a real feather in your cap. But if you haven't got it, don't touch it. Talk to people who are qualified for it. So I guess that's pretty much it. Just land on our landing page here that sort of just describes a little bit more about what we do at MEC as a business, and I'm happy to take any questions that have come up throughout the course of the presentation.
Erin, we've got a couple that have come through, so
Okay.
I'll kick off with John Simmons. The question is,
hi John.
Future climate conditions. To what extent should climate change predictions be utilised when the client or the regulator may have potentially ignorant and contrasting views on what this means?
Yeah, this is a really, really good question, John. And I think it's one of these things where you'll typically have a closure team that are assigned to do this. And I guess you kind of have to work with within that team and start generating that conversation. And sort of start creating some scenarios. Might be a good example of how you could, get your point across. So, if the climate looks like this is what you're looking at. This is the footprint. If it looks like this is the footprint. So, do you want to revisit this in 10 years' time when this event happens, or and you'll often have some understanding of what the variance is in what that footprint would actually be. So work with your closure team. More than likely, the people on your closure team are probably going to have an understanding of what the government expectations, what the company expectations looking around that, and you can provide guidance on what the variance would look like. At the end of the day, provided that you've done that evaluation and you put that forward and you've documented it, I think you've done your bit to help the company to understand what their risk is.
Thanks, Erin. I've got another one. Long-term degradation and erosion are geomorphological factors for which geotech analysis and FOS are inappropriate. How best to introduce this consideration to both client and regulator?
Yeah, so there are some things that you can actually do in your modelling, such as disturbance factors and the like, and sort of have a look at what your parameters might be, distance from the slope, residual shear strengths and the like, that you think are likely to be considered. From an erosional perspective, there are hydro geos out there who have models for understanding how these processes work. Really, the end game here is to understand how to actually, prevention is better than cure. So how do you actually stop that from occurring? So you can set up a plan and monitor that over time, so making sure, once again, you're not doing something that you're not necessarily qualified for, and you're seeking the help of people who have really good detailed understanding of these processes and how to apply them in these long-term environments. A lot of hydro geos in civil contexts would have a really good understanding of how that works, and certainly we tapped into that resource.
Another one, Erin. What alternatives to crest exclusion bunds can be considered? Is it even practical to use bunding or fencing when we go to national parks to enjoy areas with cliffs and erosion that are scenic and beautiful without fencing of bunding?
Yeah, once again, I think that's going to be one of those grey areas that you're going to have a discussion and get approval from the government around. So you can, once again, create a scenario, draw up a plan, work with your closure management team, and you can present that to the government. But at the end of the day, they're going to be the ones that are going to call the shots on approve or don't approve. You can certainly present the case for that and consult with the community and see if they're interested in that, to help sort of, I guess, bolster that argument. But yeah, there's something that I wouldn't make a specific recommendation on. I'd want that to be a consultative process and making sure that I was generating some scenarios that would benefit or showcase it.
Great. We've just had a comment come through. So great question on erosion, and something we as the coal industry should be more aware post-closure. Thank you.
Absolutely.
I don't have any other questions. To all the attendees, do you have any other questions that you'd like Erin to answer? No.
Excellent.
That's all right.
Okay.
We'll leave that there. Thank you all for joining. We will send through a recording of the session. And if you have any questions, please reach out to Erin. I'll also send you her details.
Lovely. Thanks, guys.
Thanks, guys.
See you next time.